Good afternoon, friends. Today I should be discussing the path of contact between the two mating gears, and we should formulate the formulation for the path of contact by which we could, by putting the values by which we could directly find out the path of contact between the two mating gears. Now let us see. The black color portion is the pinion and the blue color is the wheel or the gear. So we see that the deep portion is the base circle of the pinion, and after that this dotted line represents the pitch circle of the pinion, and the topmost black color line is known as the addendum circle of the pinion. Similarly, for the wheel is the deep color is the base circle of the wheel. The second deep color represents the pitch circle of the wheel, and the last deep color represents the addendum circle of the wheel. Now we could see that the pinion is a drive unit. The pinion is driving the wheel. So the pinion is providing the main power to drive the wheel. So now we could here look at the contact of the two gears will be made when the addendum, please note, when the addendum circle of the wheel is in contact with a common tangent, which is also known as the action line. The common tangent, which is also known as the action line, over here it is EF. So the contact is established between two gears when the addendum circle of the wheel is in contact with the line of action or the common tangent between the two mating gears, that is at point C. Now the P, as we have discussed, is known as a pitch point, where both the pitch circles meet is known as the pitch point. Now the contact will be go on as the contact, the C is made. Now the both of the power is transmitted and both the wheels are in contact. Now when the addendum circle of the pinion touches the D, or touches the D of the line of action, here it is the line of contact is broken. The path of contact is broken. So the path of contact basically starts from C, where I am once again repeating, where the addendum circle of the wheel is in contact with the EF or the line of action or the common tangent, and it is broken when the addendum circle of the pinion is in contact at a point D. Addendum circle, the contact is broken when the addendum circle of the pinion is at point D of the common tangent EF or the line of action. So we could see that DC is the path of contact. So DC is called as the path of contact, where P is called where PC is called the path of approach and DP is called the path of recess. So PC over here, you could see it could be broken in two parts. The path of contact, PC is called the path of approach and PD is called the path of recess. Now over here we could take certain conditions. We say R is we represent small r as the pitch circle radius of the pinion, small r as the pitch circle radius of the pinion, and capital R as the pitch circle radius of the wheel. So this small r is taken from here to here. The small r, that is the pitch circle, that is the connecting the center to the pitch circle. So small r is represent the pitch circle of the pinion, and the capital R is not shown over here, is shown represents the pitch, that is the from the center line to the pitch circle, that the radius of the pitch circle is represented of the wheel is represented by capital R. Capital RA is the addendum circle radius of the wheel. Capital RA, this has been shown, is the addendum circle radius of the wheel, and small ra is the addendum circle radius of the pinion, the last circle, the pinion. Now over here we could see that the pinion is rotating in the clockwise direction and causing the wheel to move in the anti-clockwise direction. Now over here we have drawn the angles. Over here we could see that now over here we represents R. What we are saying that the R, which is the pitch circle radius of the pinion, is represented over here. Small r, the pitch circle radius, this is the R, small r, it represents the pitch circle radius, and capital R represents the, this from here to here represents the small r. From this point to this point represents, that is from A to P, represents the small r. I'm showing it. This is the small r, this is the distance, this is represented by small r, and capital R is represented from this point, that is from B to P represents capital R, or the radius of the pitch circle of the wheel. Now we could see that the path of contact is normally called the path of approach and path of recess. Now path of approach, as I've told you that path of approach is C to P and path of recess is D to P. So we are writing that the path of approach as C, P and PD. Now we could break CP into CF minus PF. Now how could you see? We could break the line CP as CP, we could, that is a path of approach CP, we could break that CF minus PF. CF minus PF. So this is called the, we could break the path CP as CF minus PF. This line CP as CF minus PF. Now, and PD, the path of recess, and the path of recess PD is broken as DE minus PE, and the path of recess D to E is broken as that is D to P is broken as DE minus PE. Now DE minus PE. So we have written like this. Now basically we are continue to write what is this CF. If you focus what is this CF, if you come to this figure, we could find out what is this CF. This is the length, this is the line CF. Now CF is basically, we could write CF like RA square. This is the RA. If we got the 90-degree Pythagoras theorem, we could apply over here, and we could write that CF is basically RA square minus r square cos square phi. So if this is r cos phi, so this portion should be this portion. So this portion should be r cos phi. If this is r, this portion should be r cos phi. So basically what is that? CF is written as RACF. So CF is basically written as this one as RA square plus root over of under root RA square minus r square cos square phi. So here you have written that CS square is equals to RA square minus r square cos square phi minus PF. Now what is this PF? PF is simply r sin phi. PF is simply r sin phi. So we have written that PF is simply r sin phi. This is cos phi, this should be sin phi. Now I have shown you that for wheel that to get the length of CF, we simply use Pythagoras theorem and find out the value of CF by RA square. This length, considering the triangle BCF, we consider RA square minus r square cos square phi under total root. So we get the value of CF, and we get the value of FP by simply r sin phi. I have told you simply r sin phi. This length from P to F is simply r sin phi. So we have written this minus r sin phi. Similarly, we should get the value of DE minus PE. Now basically, what is DE? DE, if you consider the triangle EAD, we could write that this length DE should be what? Total root over of r square cos square phi, total root over of small r square minus small r square cos square phi. So we have written this r square minus r square cos square phi. And what is this PE? And what is this basically PE? PE is basically nothing but RA sin phi. If this is cos phi, then PE should be RA sin phi. Then if considering the triangle EPA, considering the triangle EPA, PA. So basically PE is considered R sin phi. So we have written R sin phi. Now if we add this together, if we replace this and put all the square roots of together, then we could get this differential formulas: r square minus r square cos square phi plus small r square minus r square cos square phi minus r plus r sin phi. So this is the equation. This is the equation which we are searching for, which represents the total path of contact, the path of contact that is CD. That this is the formulation of the CD. There is a path of contact of CD, and if we know the value of the radius of the addendum circle and the pitch circle of the wheel, and that of the addendum circle and that of the pinion, the addendum circle and pitch circle of pinion, and we could easily find out. And if you know the value of phi also, we could normally we should be the pressure angle. So if we put the value, we could easily calculate the value of path of contact. So this is all about up to the path of contact what we have discussed in the topics in this lecture. So if you like my way of delivering the lectures, you can put a thumb mark to the lecture, and if you want, you can subscribe to my channel for more videos like this. Thank you for watching the video. Have a good day.